we're involved in, would you believe, Internet of Things. The Internet of Things, it's something that we've heard a lot about all afternoon and all through the day, in fact. But the Internet of Things, it isn't actually a thing at all. The Internet of Things, as we all know, is it's really a concept more than a thing itself. It's the concept of data from all sorts of places that we wouldn't have expected or thought about being gathered together for a purpose. Now the purposes, they can vary immensely. What I'd like to talk about is how the whole manufacturing technologies, the whole manufacturing and industrial sector can benefit from implementation of the capacities that the Internet of Things gives us. Now we've seen some of the examples earlier on about the personal data, healthcare, and so on. Here we're going to look at what happens inside of the factory as we manufacture things, as we try to improve our manufacturing process using what the Internet of Things can give us. We've developed in the past years techniques to gather data about our production process. Elaine earlier on mentioned how we get people in factories gathering data on a clipboard, putting it into Excel worksheets, to the point that we have no reliable, true source of data. We have data from all over the place. And it's a fact that 95% of the Excel spreadsheets in the world have errors on them. Now that's a huge proportion of errors. What it means is that the data that's being fed into our very expensive, very, let's say, well-engineered enterprise resource planning systems and our manufacturing requirements planning systems is false. I mean, this is one of the reasons why we frequently have a gap between manufacturing conditions and we're very far from an optimal situation. Excel, of course, is something that's very useful for getting insight to data, but first of all you have to have the accurate data, otherwise the insights you might get can lead you down the wrong track. We've seen that enterprise resource planning systems allow us a great deal of control over the whole enterprise processes between manufacturing planning, between sales, linking all of the functions within an enterprise to the requirements of the market and of the various costs of each department. Now, all of this naturally results in a very complex situation for our managers, for our middle management, and even for C-level strategy deciders and so on. The problem being that it's very difficult to make sense of so much data, hence data analytics. Big data systems are being brought in, as we know. We've seen some of the applications of these systems. We've seen that it's possible to gather information from all sorts of places within an enterprise and from outside. We talked earlier on about how social media can be used for marketing decisions, for product development decisions. Well, it can also be used, we can also integrate into our data analyses, data coming from the manufacturing floor. Now, there's all sorts of applications we can think about. If you take meat factories, for example, we all know that you have sides of beef coming into a meat factory. It gets cut up into little chunks and ends up being packaged, perhaps in sausages or some other products on the way out. But it's very difficult to make a correlation between what goes in on one end and what comes out on the other end of the factory. And this is where the manufacturing data is important. If we can gather it from the shop floor, then we'll be able to make some kind of a sense from it and use it in terms of organizing and optimizing the factory process itself. Similarly, we've got a number of data sources that we have to look at. data from the shop floor. It could be things like weight for packages. It could be things like density, physical measurements, information coming from machine recognition systems, from visual computerized recognition systems, and so on. What we need to do in terms of making this work is ensure that the IT systems are in place, that the operational management is fully informed and trained and up to speed on what can be done, what the new level of integration of this information can bring us. We've seen manufacturing systems that have been implemented all around the world have a lot of automated equipment. Very rarely you'll see that this equipment is interconnected. You have systems such as our earlier presenter mentioned, the things that operate traffic lights, the things that operate access barriers and so on. All these are automated systems. They're very rarely interconnected to the point that what's happening on the system, on the machine, is actually known about elsewhere than locally to that machine. Sawmills, for example, you have furniture factories where systems are automatically slicing up trunks of trees into planks and making chairs and furniture and so on, but nowhere is that information being used to determine exactly what increase of stock is happening, what decrease of raw supplies is happening, and so on. So what we have to do is to make sure that that information is captured on a local level in the shop floor and sent back to the overall enterprise management systems. The technology that we can implement, we can use this to enhance warehouse management. We can use this to make it to make a manufacturing operation concentrate on the elements that will actually generate profit and reduce down to the minimum the inventories that are needed. We find that the latest systems, the latest automated systems, are interconnected in such a way that the data is uploaded to the SCADA networks inside of the company, and we've talked about that earlier on. There. We apologise for this technical interruption. One of the things that the Internet of Things actually enables is the use of computer-integrated manufacturing. We all have seen 3D printers in operation. One of the big advantages of a 3D printer is that it reduces down to nothingness the need for long lead times in terms of product development. When we need a new product, we don't have to negotiate with our suppliers to set up a new assembly line. We don't need to reprogram our own assembly material, our own PLCs and whatnot. We simply print the new products. We don't have inventory. This means that just in time, it's no longer relevant for what we can print on a 3D printer. Similarly, we can reduce our ICT expenditure by using cloud services. So the convergence that we're talking about is that using the techniques from what we call the Internet of Things, or Manufacturing 4.0, we can gather together all of the data with far less errors than we've seen in the past. Nobody walking around with a clipboard, no multiple versions of the same data within a company. And this can be brought down to the level of warehousing, for example. We can know exactly what's come off of our assembly line. We can our ERP systems, our enterprise resource planning systems, can be accurately informed of what's in inventory. This can be managed so that when we know that there's going to be a forthcoming sales rush, we can have the adequate inventory in place. We can even put together systems for automatically managing the warehouses, for finding material, different references, Today we've got systems that we can put in place that give accuracy of the positioning to within a centimetre. Cloud ICT services, as I mentioned, today we no longer are limited in terms of ICT. We can have our own design services, relying on outside computing resources. Some of our other presenters this morning have given examples of how high power computing can be made available to enterprises at every level. Manufacturing processes. One of the things that we've worked on in ICT Forge includes a system where we took a producer of ice cubes. It's a very simple product. You take water, freeze it in cubes, put it in a plastic bag, and deliver it to the customer. Now, the problem that we found was that 20% of the ice cubes, for some reason, disappeared. Now, part of it was due to, let's say, inadequate manufacturing process. Part of it was due to theft. The long and the short is that we put a system in place that measured, using a visual recognition system, measured the size of each ice cube, weighed each ice cube, determined the proper content. We were able to track practically every single thing that was made. The ice cubes are identified, put in the bag is tagged, and it's tracked through to delivery to the customer. The net result was that from 20% loss we went down to 3% loss. This is the kind of process that can be applied to pretty much any manufacturing process. There are many parallels. Another one of the projects that we've been working on is a research laboratory. That slide seems to be modified. A research laboratory system where we integrate CNC milling machines, computerized integrated manufacturing, that's to say a 3D printer, together with an automated system for moving components between the different workstations. It's actually a drone. So that's currently in the process of being implemented at a technical university. That's the diagram of the system. We have various workstations, a 3D metal printer. So that's not a plastic printer; it's a metal printer. We have the overarching enterprise resource planning software, which is controlling the operations of the printer, which is controlling the operations, in fact, of the whole transport mechanisms that are going on here. So an instruction is given to manufacture a device. The device then goes to a manipulation station. Flanges are cut off. So there's a dexterous robot. It's then sent over to the logistics area, and all of this is a fully automated process. So that's the kind of thing that is going to be happening in the future. We'll have no need to reconfigure an assembly line to go around reprogramming PLCs every time that there's a new product design, or every time that something changes on the deliverable. Here we can do this directly, controlled directly from the ERP systems. Now there's a number of steps obviously to go through before a factory can implement IoT manufacturing techniques. This is the kind of thing that advisory services are required. The network infrastructure has to be validated. Networking security, it's a very serious concern. Anything that can control equipment, manufacturing equipment, has to be impossible to hijack or to take control remotely from. Similarly, the ICT services that are required has to be evaluated, and all the way down to the actual physical sensors that are required on the assembly line processes itself, and on the assembly line equipment in particular. Thanks very much for your attention.